Okay, we need to go through how to do this again because it was not very good. Now, the first thing you're not doing is you're not drawing on your pictures like I've told you to. Okay, so when I look at this question, I see set up but do not integrate cross sections perpendicular to the x-axis. So over on your picture, what we're doing is we're sketching in. These are the bases of my cross sections that are perpendicular to the x-axis. Now, what you need to see here is that you're going to have to do this in two integrals. So this first region to the left of this dotted line is being controlled by the blue curve. So the top and then the bottom is the positive quadratic minus the x-axis. Now I'm going to have to do two different integrals because this section is being controlled by the red curve, top to bottom. You need to actually draw on your sheets of paper. Okay, so now when I set this up, I have to set up in two different integrals. I have to have an integral for the blue section, and then I have to have a separate integral for the red section. They're equilateral triangles, so my coefficient is the square root of 3 over 4 for both of them. All right, now the limits are the x-coordinates where I start and stop this region. So the x-coordinate here is going to be a 0. The x-coordinate there is 1. That's the intersection of these two things. I can get those from my calculator. The next integral picks up where the other one left off at 1, and it stops at the square root of 3. The square root of 3 is where I hit the x-axis. Again, you can find that in your calculator. Okay, now I need to set up my heights of these. So when I'm doing cross sections, it's the base squared. So my base is the top minus the bottom of that blue line. So the top function is x squared plus 1 minus the bottom, which is the x-axis, quantity squared. And then the red section, the top curve, is the negative quadratic minus the bottom curve, which is the x-axis, quantity squared, dx. So when I set up cross sections, it's the integral with some coefficient out front of top minus bottom, quantity squared, dx. If either the top or the bottom changes, you have to start a new integral. This was two different integrals because the function that controlled the top of your base switched. Question 12, which the big change in question 12 is that you're perpendicular to the y-axis, meaning when I draw my lines are being drawn this way, perpendicular to the y-axis. This one also has to be done in two different integrals because you have two different regions. This region is being controlled by the red curve to the y-axis, so it's right and then left. Now the next region is different because it's being controlled by the red curve to the blue curve. That's the left. These are the bases. Remember what we have here are squares coming up off the page. Right to left, right to left. If either section changes, you have to have a new integral. So I've got semicircles. So I got two integrals. They're both semicircles, so pi over 8. My limits are y values. Everything's a y value. dy, dy, dy. We're adding them together. So the first region is this region here. Okay, the y value where that starts is 0. And the y value where it stops is going to be the y-intercept of the blue curve, which is 1. The second region, which is this one here, is going to be the y value where the other one stopped until the y value where they intersect, which is a 2. You can get that in your calculator. Okay, now we're thinking right minus left. So the right function is the downward parabola, which you have to solve for x. So it's the square root of 3 minus y. That's the right. The left is the y-axis, quantity squared. And then the next one, I'm going to solve it for y. Sorry, solve it for x, but in terms of y. So the downward parabola is the right edge. The upward parabola is the left edge. Okay? Upward, downward. The downward parabola is the right edge, so the square root of 3 minus y. The leftward parabola is this one, quantity squared. This represents the distance between the curves, which is serving as the base of this cross-section. This represents the distance between these curves, which is serving as the base of these cross-section. I'm adding them together.